Hello viewers, welcome to Big Boy Physics. In today's session, it's another lecture of basic maths, and from today we'll be starting the topic of calculus. Okay, so let's get started. In calculus, you might have been thinking about differentiation, integration, all those, but I'll be starting with a bit of function, of course. Now, what is a function? Function is like a machine. It's like a machine. Suppose जैसे कि यहाँ से कुछ दिए जैसे कि ब्रेड दिए एक एक कॉर्नर से ब्रेड दिए फिर चीज़ दिए और दूसरी तरफ से तुम्हें सैंडविच मिल रहा है। मतलब जो मशीन है ये एक फंक्शन की तरह काम कर रहा है जिसमें तुम डोमेन में कुछ डालोगे और तुम्हारा आउटपुट में कुछ आएगा, इनपुट में कुछ डालोगे तो आउटपुट में कुछ आएगा। जैसे कि ब्रेड और चीज़ डाले तो आउटपुट में तुम्हें सैंडविच मिल रहा है। सो वी कैन से दैट फंक्शन इज अ काइंड ऑफ अ something we define in mathematical language that if we give any output we'll get some kind of input. Suppose we have a machine and let us denote this machine to be f of x where x is the value we are putting inside the domain inside the input and we are getting some value y as the output. Now we are given a table y as a function of x. So it's like 1 2 2 5 3 10 4 17. Now if you observe the value you can see that it's written as y is equals to x square plus 1. This implies that y is basically output of this function. Y is basically the output of this function. That's why we also denote y as y is a function of x, which is written as x square plus 1. So y x is actually a function which operates on x and returns you the value of x square plus 1. Okay. Now this is the result. So taking few examples. Suppose you have example is f of x is equals to x square plus 3. You have to find f of 0. F of 0 is 3. Put it x to be 0 and you'll get 0 plus 0 square plus 3, which will come out to be 3. If you are asked to find f of 1 is 1 square plus 3, which is equals to 4. Right? They may ask you about f of 1. What is f of 1? 4. So put 4 inside the input. So f of 4 is 4 square plus 3. You will get it to be 19. Right? Hope you understand the basics of function. This much is enough to know for function. You do not need to go in much deeper sense. You will be taught about function in class 12, so don't need to worry. There will be taught about codomain, domain, range, and other stuff. For now, that's enough for knowing function. Another thing you must have studied in class 10 that y is equals to ax square plus bx plus c. This is also a function y in terms of x, and you may know that this is basically a representation of parabola. This equation corresponds to a parabola. So yeah, whenever we define a function we actually denote some kind of relation, and we can also plot them in a graph also. In our 10 plus 2 standard we generally discuss with y and x as variables. That is why it's generally plottable in a 2D plane graph. I hope it's clear. Now coming to the next portion. The next portion is about differentiation. What is differentiation? The word inside has meaning different, differentiate. Differentiate means distinction, to break up thing. मतलब जैसे कि तुम्हारे पास कुछ चीज़ें हैं और उनमें तुम्हें अगर पार्ट बाय पार्ट करना है तो क्या करोगे, तुम इसे तोड़ने का कोशिश करोगे बेसिकली। तो एक पार्ट तुम्हारा 3 ग्रुप्स बने, इसमें ए आइटम मिला, इसमें बी आइटम, इसमें सी आइटम। तो डिफरेंशिएशन बेसिकली वही इम्प्लाई करते हैं। पार्ट बाय पार्ट तोड़ने जैसा है पर ये पार्ट बाय पार्ट तोड़ना नहीं है। ठीक है, इसमें कुछ तोड़ फोड़ कुछ लगाने नहीं वाले, बस सिंपल कॉन्सेप्ट है कि हम लोग जब डिफरेंशिएशन एक फंक्शन को डिफरेंशिएट करते हैं हम उसका रेट ऑफ ग्रोथ को चेक करते हैं। When we differentiate a function, we try to predict the rate of growth of one variable with respect to the another variable. Okay. So now before coming to differentiation, I'd like you to know a bit of just something interesting. Suppose this is x coordinate, this is y coordinate, and I have a function somewhat like this. Consider this to be some point P, and observe that if the point P moves by some distance, for now I am representing it to be delta x, then what will be the corresponding change in delta y? This is basically we are interested to know. Okay. Suppose this graph corresponds to y is equals to f as a function of x. Now what we do is to find the change, we'll be doing what is f of x plus del x minus f of x will be change in y. Now what is the change of y with respect to x? So del y by del x is the result, which will come out to be f of x plus del x minus f of x by del x. Now in mathematical terms, what we do, we represent this del y, which is a very small number, to be as dy, and del x to be as dx. So what I'll write is dy by dx is equals to f of x plus dx minus f of x by x plus dx minus x, which will get to be limit. We also represent it as like this: limit t tends x f of x f of t minus f of x by t minus x. This is also written as f dash t, that is the derivative of function at some point t. Now here we are taking, sorry, it will be at x because we are taking the point to be x. Now if I represent this to be x naught, then we have to take with respect to x naught. Okay. So we need the derivative of the function at x equals to x naught is basically given as limit t tends x naught f of t minus f of x naught by t minus x naught. So that's the result. Well, it's a very important result, and this is the whole thing we'll be using in differentiation. Okay. Now coming to the important formulas, the formulas which you need to know. Suppose you have the function f of x is equals to y x square. Okay, y is equals to x square. Then can you tell me the f dash x at some x is equals to x naught? You can write it as limit t times x naught uh, t square minus x naught square by t minus x naught. To do this in a limit evaluation, what we'll do, we'll substitute t as some x naught plus h, where h is a some kind of quantity which is very small. T is a very small quantity. So now what we'll do is limit t tends x naught plus h whole square, or else we can write this to be as limit h tends 0 h naught plus h whole square minus x naught square by h. So you can write this limit h tends 0 x naught square cancel, and putting it as a minus b into a plus b, you will get h into 2 x naught plus h by h, cancelling the h, and since h is much less than, is a very small quantity, so you can almost write it as 2 x naught. So yeah, we can say that d by dx of some function x square is equals to 2x for any x, you can say. Now similarly, we'll be deriving for some x to the power n. For y is equals to x to the power n, d by dx of x to the power n can be written as x plus h whole to the power n minus x to the power n by h, limit h tends 0. Okay. Now if you know this simplification, you might know about that it will come out to be x plus h minus x into x plus h whole to the power n minus 1 plus and so on. Or better, you can write that for h much less than x, we are considering general values of x. So I can say x plus h whole to the power n is x to the power n into 1 plus h by x whole to the power n. Now if you know about binomial theorem, you must know one thing, that 1 plus x whole to the power n can be written as 1 plus nx plus n into n minus 1 by 2 1 into 2 x square plus n into n minus 1 into n minus 2 by 1 into 2 into 3 x cube, and this goes on. So I can write x to the power n into 1 plus h by x whole to the power n as x to the power n into 1 plus nh by x plus n into n minus 1 by 2 h square by x square, and so on. Now this expression is subtracted from x to the power n, so minus x to the power n by h, cancelling one x to the power n. Then you will get x to the power n into n by x plus some terms which contains this h terms. Okay. Now since h is very small, so I can say this to be 0. Hence I will get d by dx of x to the power n is given as n x to the power n minus 1, and that's the answer. Okay. Hope you get it. Now similarly you can take another function like for d by dx of sin x. Now I must have said you that sin x plus h minus sin x by x plus h minus h, you will get it to be nearly 2 sin h by 2 into cos x by, here it will be x by h. And you must know another thing, that sin x by x for x tending to a very small value is written as 1. So you will get sin h by 2 upon h by 2 into cos x. This comes out to be 1, hence you will get the result of cos x. So dy dx of sin x is equal to cos x. Okay. Now this derivative of a function, suppose we define dy by dx for y is equals to f of x. This is also called the differential coefficient of f of x at some point, suppose x equals to x naught. Okay. Now coming to few formulas, we'll be learning about few formulas. Now if I come to derivation, it will be very lengthy, so I'd like you to remember all of them. Okay. So first is d by dx of x to the power n is equals to n x to the power n minus 1. Second is for y is equals to sin x, d by dx of this function sin x is given as cos x. Third, dy dx of cos x is given as minus sin x. Fourth, dy dx of e to the power x is equal to e to the power x. Now, if you have any confusion about e, then I hope that you most of you are being taught about logarithm in the first portion of mathematics. The first chapter of mathematics is fundamental of mathematics, in which you are taught about logarithm and all those stuff. So yeah, don't no need to worry. E is basically a number. E is written as nearly 2.718. Okay. Now E is basically a number. So don't worry about that. You may, if you don't know about it, you'll be learning it soon in mathematics itself. Okay. So E is basically a number, and differentiation of this function e to the power x with respect to x is written as d e to the power x. Now coming to fifth formula, another function you will get is y is equals to ln x. Then in that case dy by dx is equals to 1 by x. If you have any question about ln x, it's written as log base 10x upon log base 10e. If you don't know about log, don't worry, you are being will be taught about log in the fundamental of mathematics wherever you study. So well, we can't cover logarithmic in physics video because it would extend the lecture of basic maths too much. Okay. And final function is y is equals to tan x. In that case, dy by dx is written as sec square x. Okay. And these are the formula you have to remember. That's it. Okay. Now coming to the new formula, new tricks, and new methods to differentiate. First is UV rule. Suppose you have a function f of x is equals to u as a function of x into v as a function of x. Then d of f of x by dx is written as du by dx, that is differential coefficient of u as a function of x into vx plus differential coefficient of v as a function of x into ux. If you want to look at the derivation, you can try it yourself, or you can also see some mathematical books. You can read it. Well, I cannot derive due to time constant. Apologize me. Okay. Coming to a question from UV rule. The question says y is equals to x square plus 1 into x square plus 3. You have to find dy by dx. Okay. Just you can do for two methods. First method is UV rule. Using UV rule, you will get x square plus 1 into 2x plus x square plus 3 into 2x. On simplification, you will be getting 4x cube plus 8x. Okay, 4x cube plus 8x. And if you try using the normal method, just expand them. X to the power 4 plus 4x square plus 3 is equal to f of x. Then df by dx is written as 4x cube plus 8x. Okay, so that's the answer. Now coming to more problems. If you want to do more problems, let's take some, what can I say, some different type of expressions rather than algebraic. Let's take it to be logarithmic and all those. If you are asked to find the differential coefficient of e to the power x log x, well, I am taking it to be, of course, ln x, not log x, ln x. So dy by dx is written as e to the power x into 1 by x plus e to the power x into ln x. What I have done here is d by dx of e to the power x into ln x plus d by dx of ln x into e to the power x. This is what I have written here, and d by dx of ln x is written as 1 by x, and d by dx of e to the power x is always e to the power x. So no question in that. And then we get our resulting answer. Okay. So yeah, we have learned about product rule. Coming to quotient rule. Quotient rule is another method to solve differentiation questions. That says that du by v, if you have a function f of x is equals to u as a function of x by v as a function of x, then you will write that the differentiation of this u by v function is with respect to x is written as v du minus u dv. I'm not writing in form of ux as a u as a function of x or vx. Okay, I'm just writing it to be u dv v du minus u dv upon v square. So this is the result. Of course, with respect to x, how can we forget that? I hope it's clear. You may also derive it like this. Take it to be u into 1 by v. You will get du by dx into 1 by v minus 1 by v square dv by dx. This is what I have applied as chain rule. We will be learning about that shortly. Don't no need to worry. Okay. So now coming to a question. Question is suppose y is equals to t square minus 1 upon t square plus 1. Find dy by dt. हमेशा क्या dy by dx लूँ, कभी तो t के रेस्पेक्ट में भी ले लेता हूँ. ठीक है. So dy by dx will be v is the denominator, so it will be t square plus 1 whole square in the denominator, and in numerator it will be v du t square plus 1 into d by dt of t square minus 1. The habit of writing x instead of t, it really feels bad, hurts, and minus t square minus 1 d by dt of t square plus 1. Now simplifying, you'll get 2t into t square plus 1 minus t square minus 1 into 2t by t square plus 1 whole square. You will get it to be 4t by t square plus 1 whole square, and that's the answer. I hope you get it. If you want to try another problem, let's take up another one. Question is y is equals to sin x by x plus cos x. You have to tell me the differential coefficient of y with respect to x. Now the same logic, dy by dx, it's written as x plus cos x whole square. Now I'm writing the direct expression, you direct calculations only. You just try to solve it quickly and check the answers. It will be x plus cos x into cos x minus minus sin x into sin x. You'll get it to be x cos x plus 1 by x plus cos x whole square. Yeah, that's the answer. Well, just a minute, there's some problem I guess in the expression. Yeah, it will be 1 minus sin x. You'll get it to be plus 1. Another minus sin x will be there in the term. Okay, so that's the answer. Now coming to chain rule. Chain rule is something which is a little bit confusing to students, but I try to explain you in the most simplest way. Suppose you have a complicated function y is equals to f of x as f of x into g of x, where f and g actually forms a composite function, and they're asking you to find the derivative of y with respect to x. How can you find it? Okay, to do this, what we do is the derivative of y with respect to g of x into derivative of g of x with respect to x. That's the key. Now derivative of f of x with respect to g of x is d of f of g of x upon d of g of x into derivative of g of x with respect to x. And in short notation we write it like this: f dash g of x into g dash x. Okay. In general we write d by dx of any f of x to be f dash x. So the same thing we have written here. Let us take some examples. You'll be getting it. What I mean. Suppose you have function y is equals to 4 e to the power x square minus 2x. What will be dy by dx? Let us explain. Suppose you take the function g of x to be x square minus 2x and f of x to be 4 e to the power x. So I can write that y is basically given as f of g of x. Hence dy by dx can be written as dy by dgx into d of gx by dx. Y can be written as f of g of x, so it can be written as 4 e to the power g of x. Hence you will be writing it as 4 d of d by dx, d by d of gx of 4 e to the power gx into what is the derivative of e to gx in terms of with respect to x. You will get it to be 2x minus 2. Now derivative of this function with respect to gx is basically coming to be 4 e to the power gx into 2x minus 2. Now substitute gx as x square minus 2x. You will get 4 e to the power x square minus 2x into 2x minus 2. And that's the answer. Hope it's clear to you. Let us take another question. Now to do this question, before taking it, to do this question in a rapid manner, how to do? 4 e to the power x square minus 2x. Look at this. This will come out to be exponential. Derivative of this exponential will be the same. So it will come out to be 4 into e to the power x square minus 2x. Now this function is a complicated one. Take it, multiply it, the whole expression with its derivative. Okay, derivative of x square minus 2x is 2x minus 2, and that's the answer. I hope it's clear to you. Coming to next question. Next question says that y is equal to under root x square plus 1. Then what will be dy by dx? Okay. So just using rapid formula. For under root x, it will be 1 by 2 root x. So it will come out to be 1 under root 1 by 2 under root x square plus 1. Now x square plus 1 is sus or complicated. Why I am using the word sus, I don't know. Okay. So it's basically a little bit suspicious function and it looks bigger. So take the derivative of x square plus 1 with respect to x. You will get it 2x. And final answer will come out to be x by under root x square plus 1. And that's the answer. For your homework, you may try another problem. The derivative of y is equals to sine x square minus 4. Okay. To do this, while doing this, you will get the answer to be 2x into cos x square minus 4. Okay. Just the same thing, d of y by d of x square minus 4 into d of x square minus 4 by dx. So this is the core concept about the differentiation of chain rule. Now another thing you'll be learning about differentiation is parametric differentiation. I'm writing the differentiation in short as DIF Fn. Okay. Now what is it doing parametric differentiation is, suppose x equals to a to the power 4 and y is equals to bt cube. Dy by dx is what? Basically we are interested in finding the dy by dx. So I can write dy by dx as dy by dt upon dy by dt upon dx by dt. Dy by dt is 4at cube and dx by dt is 3bt square. You'll get the answer to be 4a by 3bt. Okay. For parametric differentiation, we can understand one thing, that we have to just differentiate numerator and denominator function with respect to t, and then finding the resulting answer, and we'll get it. But probably I have done a mistake. Yeah, it will be basically in reverse. That is, it will be inverse or reciprocal. It will come out to be 3bt square upon 4a t cube, and answer will be 3b 54a t. Okay, so that's for parametric differentiation. Last but not the least is double differentiation. Double differentiation. In while discussing about differentiation, I have said you that differentiation helps us to find the tangent at a given point. But what about double differentiation? Double differentiation, the utilization of double differentiation is, it helps us to determine the nature of curvature. The nature of curvature at a given point. Single differentiation or just dy by dx gives the slope, but double differentiation gives the curvature. And we write double differentiation to be dy by dx and differentiation of this, and we represent it as d2y by dx2. Okay. For example, you have f of x is equals to x cos x. Then if you are asked to find f double dash x, that is the double derivative of f of x with respect to x, you will get it to be cos x minus x sin x as the first derivative, and double differentiation, it will yield you minus sin x minus x cos x, and answer you will be getting is very interesting. It will be minus 2 sin x minus x cos x, right? So it will again be some kind of f double dash x plus f of x is equals to minus 2 sin x, right? This actually looks like a equation of forced oscillation, or rather may not. I don't know what I can say. So yeah, so that's it for today. In this video, we learned about basic manipulations and how to differentiate functions and what are the keys of differentiation. How let me give you a review of today's. First, we dealt with what is the different definition of function, and then we dealt a little bit of limits and how derivatives are basically derived. So basically, it means that this tangent to this curve is dy by dx, and this is the application of differentiation which we'll be doing in the next video. Okay. Now coming to the next part, we discussed about some important formulae. First, this is the binomial theorem. Okay, I may not have used that term in previous. This is called the binomial theorem, and this I have derived the derivative of few function like sin x and x to the power n. Rest of them, I if you may take these derivations of this six function in your homework. You can do well. Let me give you some more functions derivatives. Now seventh which I'll give is d by dx of sec x is written as sec x tan x. Eighth you'll get is d by dx of cosec x as negative of cosec x cot x. Ninth, dy dx of cot x is equals to minus cosec square x. Now you may learn about derivative of some hyperbolic functions also. You can search for them in your Google and learn about them. Next we learned about UV rule, then about this problem and how to apply UV rule in here. Then about quotient rule. Okay. Before leaving the video, I'd like you to take a question in your homework. If y is equals to x to the power x, find dy by dx. Take this question to be in your homework and comment me in the comment section that what will be the answer. I will reply you as soon as possible. So thank you. Have a nice day.